If you were given a piece of ordinary steel, how would you cut it? Clever, you must have thought of using a bandsaw blade. First, you laser weld the saw blade's backing material, spring steel, and the tooth material, M42 or M51 high-speed steel, to create a composite steel strip. Next, you send this composite strip down to the workshop. You stretch it, pull it, wind it around giant coils like you're taming a metal serpent. All this to make it flatter, stronger, and ready to flex. The third step is to feed the steel strip into a large stamping press. The press performs continuous stamping on the strip to shape the saw teeth. For some tooth profiles, a set process is used. The teeth are pressed and bent alternately left and right by a mold to form a curve so the blade doesn't get stuck mid-cut. After the teeth are stamped out, the steel strip undergoes further heat treatment, quenching and tempering. First, the toothed bandsaw blade is heated to 1200 degrees Celsius in a high-temperature furnace and then rapidly cooled, that's quenching. Then, the quenched saw blade is reheated to a lower temperature, held at that temperature for a period of time, and finally cooled, that's tempering. Finally, you blast it with sand, like a day at the beach, but for metal, to clean off the scale. Makes it shiny, resistant to rust, and extra wear resistant. Finally, you spray on your genius brand name and model number. And just like that, a bandsaw blade is finished. But wait, can you ship it? No way. The finished saw blades can't be directly sent to customers. You need to cut them into the correct sizes according to the parameters of the customer's sawing machines. Then, weld the two ends of the cut blade together to form a loop. This way, it can fit over the customer's sawing machine. After that, grind the welded joint until it's smooth and flat, and put a protective cover on the saw blade to prevent the teeth from being worn during shipping. And finally, box it up and ship it out. Congratulations! You've made a bimetallic bandsaw blade. Now you can use it to cut ordinary steel. But then, disaster. You try to cut a high-temperature alloy, and your blade gives up after 2 seconds. The alloy? Barely scratched. So you, the ever-clever innovator, have another light bulb moment. This time, you punch bigger pockets into the spring steel and braze on pre-made carbide tips. These little gems are made separately, tungsten carbide powder mixed with cobalt, pressed into shape, and sintered at nearly 1500 degrees Celsius. Each one is already sharpened and ready to party. Congratulations, again. You just invented the carbide-tipped bandsaw blade. It laughs in the face of high-temperature alloys and stainless steel. However, these two types of saw blades don't perform well when dealing with harder, more wear-resistant, and more brittle materials, such as ceramics and graphite. They often cause tooth tip wear and cracking of the material being cut. So, how to solve this problem? With your extensive knowledge, you shift from cutting to grinding. No more punching teeth. This time, you use electroplating, metal ions slowly building up a matrix that locks diamond particles onto a smooth steel band. Depending on different cutting needs, you can plate continuous teeth, interrupted teeth, and Great Wall teeth, a zigzag tooth pattern resembling the Great Wall. Congratulations! You've invented the diamond bandsaw blade. Okay, now, you've mastered all the bandsaw blade manufacturing processes. It's time to start your own bandsaw blade production factory.